sure you know your social security number, because you need to have that to set up the idea. So, and if you're, and you you'll pretty much know right now, based upon your grade, if you're going to take the credit or not at the end. So if you think it's a possibility, definitely want to get that set up. Okay. So, company had a profit of $3,500,000 in its first year. Since then, the company's profit has decreased by 12% per year. If this trend continues, what is the upper limit on the total profit the company can make over the course of a lifetime? Okay. So, a nice problem, an application problem. Okay. Now, sometimes it might be helpful for you to write out some terms in the sequence. Okay. So, how much profit did they make their first year? $3,500,000 right off the start. Okay. Their second year, how much money did they make? $4,200,000 would be 12% more, right?
Hang on.
What? 3,458,000. That's only 1.2%, not 12%. What do you got? 3,080,000. How much did they make in their third year? How much? 3,700,000. So they made more money? 2,700,000. How much, Nathan? $400? I think it's important to have all those digits. And that's going to continue on forever, right? Okay. So my question to you is this. Is this an R case or is this a D case? It's an R case? Why is it an R case? We're subtracting a different amount, right? Okay, all right, so it's an R case. What is R then? We get going? 0.88. multiplying by 0.88 every time. Now, if you think about it, okay, if our profits never change, what will we multiply by if they never ever changed every year? Multiply by 1, right? In terms of our percentage, what is 1? What is 1 in terms of a percentage? 7 of you yelled at the same time, so I couldn't hear. What were they again? One at a time? It's 100%, right? Okay. 1 is 100%. So if I'm losing 12% every year, that leaves me with 88% per year. Okay? What is 88% in decimal form? 0.88. Okay. So, back to our problem. If this trend continues, what is an upper limit on the total profit the company can make over the course of its lifetime? Okay? So what does that mean? What are we looking for there? What does that sentence mean? So what does that mean? What do we got to find? Do we know how long this company is going to be in business?
No.
Is it going to be 10 years? 20 years? What, Trent? Well, I said, good question. Will it ever, I don't know why I said it 3 times, be zero? Will we ever make $0? Okay. Okay. So let's say like 50 years from now, what are we making? Probably making what? Under $100? Let's see. 3500123 times 0.88. What did I say? 50 years from now?
Yeah.
We're making. Actually, we're still making $6,663.75. 50 years from now. Okay. So let's go 100 years from now. Now we're only making $11.16. Okay. All right. But when you think about it, what are we trying to find? You were on it, Cal. What are we trying to find? What does sigma mean? What does sigma mean?
Total.
Sum, right? We're basically looking for an upper limit on the total profit the company can make. We're looking for the sum. Okay? And we're going to go out to infinity. Okay? Because it doesn't say that we can't. It says over the course of the lifetime, we don't know when this company is going to end. Okay? There's many companies that have been around for more than 100 years. Okay? Can I find this infinite sum? Why? Why can I find my infinite sum?
Oh, because it's under 1. Because the R is under 1.
Your R is between -1 and +1, right? Okay. So our R value is between -1 and +1. So we can find the sum here. So the infinite sum is going to be my first term, 3,500,000, divided by 1 minus 0.88. So, how much money are we making if this were our company? How much money is our company making? What? Okay. So our company's making $29,166,666.67.
How do you get it on the graph tab there to show like the whole number? It's like when I do it, the thing goes.
I know what it does. I know what it does. Yeah.
It's like up something.
This is the third time that I've told you. Okay. Push up and then hit enter. Okay. So if you're going to use those calculators, know how to use them. You know what I mean? Okay. Otherwise, take the other ones that are over there. Okay. Yeah. Okay. But then now, and then so now like this word, like let's say tomorrow on the quiz, you got to clear off that line before you do your next one, or hit enter again. You know what I mean? Because otherwise it stays on there. Just so you know. Okay. Okay. Go for it. What'd you guys come up with?
Never.
Never?
2 seconds. Yeah, 2 seconds.
Are you a Greek mathematician? Yeah. Because that's what the Greeks thought. Oops. Mm-hmm.
This is why we don't have that thing.
This is exactly why we don't have nice things. Okay? Greek mathematician Zeno said no. Okay? This is out of your book. If you got your book, it's in the 12.4. It's number 40. Okay? His reasoning was as follows: so at 0 seconds, so at the start, the tortoise is 20 feet away. Okay? So I'm Achilles. My cart way over there on the other side of the road is the tortoise. Okay? All right. After 1 second, where's Achilles? He's at 20, so he's where the cart is. But where's the cart?
Cart's probably about 20.
Cart's 10 more feet out, right? Okay. Alright? So this is after 1 second. Then, what Zeno was saying was then, for Achilles to get to that spot where the tortoise is, it would take half of a second. Correct? Okay, because that would 10 more feet, he's running at 20 feet per second. Okay, half of a second to get to there. But where's the tortoise? Half of a second later. 5 feet out. Okay? And then he kept saying that, so then after 2 seconds, and so on and so forth. But there's a flaw in his thinking. He's saying that, Zeno is saying that Achilles will keep having the distance, but will never catch up to the tortoise. Okay? What did you guys come up with? 2 seconds, right? Because if you think about it this way, at t equals 0, Achilles is here, and the tortoise is 20 feet away, right? Right? Okay. At t equals 1, Achilles is now here, but the tortoise is at 30. At t equals 2, the tortoise is at 40, and so is Achilles. Okay. The problem with the logic that they had set up was that the time frame here kept changing. Okay. And the time frame was different. Okay. Right? So that eventually when this goes to 0, this also goes to 0. But this goes to 0 at t equals 2. So that 2 seconds is both at the exact same. Okay? Okay? So sometimes the point of this problem was, yes, we could have done it using infinite series. Right? But did we need to? No. Sometimes logic takes over. This one's due tomorrow.